signal if it accepts discrete time signals at its inputs and generate discrete time system. So its input will be denoted by u of k, and it will be equal to u of k capital T, and output will be y of k, it will be y k of capital T. Capital T is the sampling period. Continuous signal, continuous time signal, and this is a discrete time signal. So if we give the continuous input and we get the continuous output, and for a discrete time signal we give the discrete time input and we get the discrete time output. Another important property is the causality and lumpedness. Causality. Now there are two types of systems, memory system and memoryless system. For a memoryless system, the output only depends upon the input at that time instant. It is independent of the input applied before or after. That is, it does not depend upon the past nor in the neither past nor future. So this is the memoryless system. Like a resistor, it is a memoryless system. So a system is called a causal system or non-anticipatory system if its output depends on the past and current but not in the future. So causal system, the output depends upon the past state and present but not in the future. It is also known as non-anticipatory. A system is not causal if its current output will depend on the future, but such a system does not exist as mentioned here. Now very important property, another property, that the state of a system. What is the state of the system? A state of the system is basically definition is the state x of t naught of a system at a time t naught. It is the information at t naught that together with the input for t greater than or equal to t naught determines uniquely the output. So for example, if we have a capacitor, then the initial voltage on the capacitor, we need that information. So voltage on the capacitor would be the state variable. Similarly, current in the inductor, it would be the state variable. So state variable, we need the information. For a state variable we need the information, previous information, to get exactly the response of the system. So using the state at t naught, we can express the input output of the system y of t, t greater than or equal to t naught. We will need the information x of t naught and u of t, t greater than or equal to t naught. So this is a example of a system with the state at t naught. A system is said to be lumped system if its number of state variables is finite or its state is a finite vector, and a system is called as a distributed system if it has infinitely state variables. So the transmission line is the most well-known distributed system because it has infinite state variable information. Another distributed example is y of t is equal to u of t minus 1. So for example, if we want to determine y of t at t greater than or equal to t naught, then we will require the information from t naught minus 1 to t naught as well. But in that interval there are infinitely many points in this interval from t naught minus 1 to t naught. So therefore we can say that it is a distributed system. So far we have discussed the continuous and discrete time signal, memoryless and memory system, anticipatory and non-anticipatory systems, the state of the system,